Okay, so second kind of prototypical optimization problem here, where now we have information about the first derivative of a function and are asked about maximum and minimum values of the original function. So this comes from the 2000 AB Calc exam. And again, this is a plot of the first derivative, and we're asked questions about the original function and maximum and minimum values. So start here. Where is a relative minimum? Now we know that wherever the first derivative is 0 or undefined are options here. So we've got -5, -1, and 5. Now we also know that where the first derivative is positive, that means that the function is increasing. The original function is increasing, and where it's negative, it's decreasing. So here the first derivative is positive, the original function was increasing and decreasing after. So that would be a max. That's going to be a maximum. But from decreasing to increasing, that would be a minimum. And we go from increasing to increasing, so that's neither. But here we go at x equals -1. And how come? Because it goes from decreasing to increasing. Relative max, well, we just figured that out. That's at -5. Similar reason. And where the second derivative is negative, well, that means wherever the first derivative of this is negative, or where it's decreasing. So anywhere between -7 and -3. And let's see, 2 and 5. So on those intervals, this function is decreasing. So from -7 to -3, and from 2 to 3. And you know, it looks like it has a vertical. It's undefined at maybe at 3. So you know, maybe something like not including 3. All right, and last one, where's the absolute maximum? Well, now what we know is we know where this thing starts. Okay. We start here when x equals -7, and then the function is increasing until -5. So wherever it is at -7, it increases to -5, and then decreases until -1 by this much, then increases by this much, and increases by this much again. So, you know, you get an increase, wherever we start, we get this much of an increase, then decrease this much, and then all of this is increased. So out here at the end point is where it's going to be the biggest, I would say. And that's just because if we compare all of this positive area under the curve to this little negative area, you know, we're going to have the most out here. So just another kind of typical problem to face in terms of maximum and minimum values here.